Hi guys, in this recording we will be talking about linear differential equation. So this is where we will be talking about the integrating factor. A differential equation which is of the form dy by dx plus p times y equals to q, where p and q are constant or they're functions of x only. This is known as first order linear differential equation. For example, you can have different kind of linear differential equations. Dy by dx plus y equals to sine x. So your p is 1 and q is sine x. Dy by dx plus 1 by x y equals to e to the power x. So again, so here also, what do you have? Your p is 1 by x and your q is e to the power x. So this time they are functions of x. Dy by dx plus y upon x log x equals to 1 by x. So these are all examples of a linear differential equation. Or you can also have a situation where instead of dy by dx, you have dx by dy. So you can have a situation where you have dx by dy, then you will have plus p1x equals to q1. P1, Q1 are constants or they are functions of y. Examples could be, the same kind of examples with dx by dy. Dx by dy plus x equals to cos y. Dx by dy minus 2x upon y equals to y square e to the power minus y, so on and so forth. Now, how do you solve linear differential equation? That is what is very important. So suppose you multiply both the sides by a function of x. If you have a linear differential equation in dy by dx plus p times y equals to q. You suppose you multiply both the sides by gx to get gx into dy by dx plus p times gx into y equals to q times gx. So suppose you do this, you multiply the both the sides by some function of x, calling it gx. Now you choose gx in such a way, that your right hand side becomes a derivative of, you choose gx in such a way so that your right hand side becomes a derivative of y into gx, which is the term that you have with p here. Okay, so suppose you choose gx like that. So that is, what do you get? That is, you have gx dy by dx plus p times gxy equals to, this side you have derivative of y into gx. You're choosing gx such that, okay, that is gx dy by dx plus p gxy equals to, if you differentiate it, so the derivative of y into gx, the derivative, use the product rule, so it will be gx dy by dx plus y into g dash x. So this is what you will get. Okay, and that implies, see what will happen, gx dy by dx cancels and you get p times gx is equal to y is equal to y is equal to g dash x, because y also cancels, so y and y will cancel, so you will get basically p times gx into y is equal to y g dash x. So y cancels and you get p into gx is equal to g dash x, or in other words, p is equal to g dash x upon gx. P is equal to g dash x upon gx. If you integrate on both the sides, what will you get? If you integrate on both the sides, Integral of p dx is equal to integral g dash x upon gx dx. This is what you will get. Okay. In other words, when you, since you know what you have here, you have gx in the denominator and g dash x here. So that means clearly you will get log gx as this integral. So integral p dx is equal to log gx. So gx, if here you have log, so gx, that means what will be gx that you have chosen? Gx will be e to the power integral p dx. So gx is e to the power integral p dx. Now we multiply the equation dy by dx plus py equals to q by gx, which is e to the power integral p dx. This e to the power integral p dx is called the integrating factor. The integrating factor, IF, of a given differential equation. This is your integrating factor. And whenever you have a linear differential equation, you multiply by this integrating factor. You substitute for gx as e to the power integral p dx. P will be there in the equation with you. So what you will do, your linear equation will become e to the power integral p dx dy by dx plus p into e to the power integral p dx y plus q e to the power integral p dx. Or in other words, what you have is, you can see what you have here. Here you have your left hand side is d by dx of y into e to the power integral p dx. That is your integrating factor. Y into the integrating factor derivative of this. You integrate both the sides. You integrate with respect to x. Then you will integrate, see, integrate is entire of the derivative. So you will just have y into e to the power integral p dx equal to integral of q into e to the power integral p dx of that. So the answer will be basically y equals to, so what will be your function y? Y will be e to the power minus integral p dx into integral of q into e to the power integral p dx plus a constant c. So what are the steps involved? What are the steps involved? Number one, you write your differential equation in terms of linear differential equation, that is dy by dx plus py equals to q. Second, find the integrating factor IF e to the power integral p dx. Write the solution. Then your solution is y into the integrating factor equals to integral of q into the integrating factor dx of that. Basically, that integral of this, the entire thing, plus constant c. So these are the three steps involved. Why and how you get this integrating factor is something that I've discussed in this video. If the differential equation is of the form dx by dy, then also the same thing will happen. Wherever you have dx, you have dy essentially. Okay. So instead of y equal to something, you will get x equal to something. Your equation will be like that. For example, let me first take a couple of examples in this video. Dy by dx minus y equals to cos x. So clearly, first of all, you identify your p. P is minus 1 and q is cos x. So you first of all identify your p. Now your integrating factor is e to the power integral p dx. So it's e to the power integral minus 1 dx. So it will be just e to the power minus x. So that's your integrating factor. Okay, e to the power minus x, that's your integrating factor. This is your integrating factor. So your solution will be y e to the power minus x equals to integral of cos x e to the power minus x dx plus c. Now here you have cos x and e to the power minus x. So therefore, you will have to use Leibniz rule out here, or you will have to use islates basically. So let me just, I'm just looking into this integral right now. Let's take integral cos x into e to the power minus x. So I is equal to integral cos x e to the power minus x dx. So that will be cos x e to the power minus x upon minus 1 minus. So suppose this is 1, this is 2. So it is 1 integral of 2 minus entire integral d by dx of 1 into integral of 2. That's what is your islates, the rule, or which we commonly call by parts. So using by parts, you will have to integrate here. So this will give you minus cos x e to the power minus x minus of, again you will have to use by parts here. So minus sin x e to the power minus x plus integral cos x e to the power minus x, which is your integral that you started off with. So that integral can come out here. That integral, when the minus sign entirely comes here, so that integral, this is just I. This is I only. So this goes that side. So you will have twice of I equals to minus cos x e to the power minus x plus sin x e to the power minus x. So this gives you that I is equal to sin x minus cos x upon 2 e to the power minus x. Now put it back in the solution that you have. Solution is y e to the power minus x equals to sin x minus cos x e to the power minus x to e to the power minus x plus c, which means that y is equal to, what will happen? E to the power minus x cancels out here, and here you will have, with c you will have e to the power minus x. So this will be your final solution. This is your final solution. So this is what is a solution to linear differential equation. And this is how you reach to integrating factor. Of course, you can now just cram it that your integrating factor is nothing but e to the power integral p dx. But why it comes, that is what I wanted to discuss in this video.